In 2022, the United States launched what many call the most aggressive technology containment campaign in modern history, sweeping export controls designed to choke China's access to advanced semiconductors and the tools needed to make them. The goal was clear: to slow China's rise in artificial intelligence, quantum computing, and next-generation defense systems by cutting off its access to cutting-edge chips from companies like Nvidia, AMD, and Applied Materials. But 3 years later, the outcome has defied Washington's expectations. Rather than crippling China's semiconductor sector, these restrictions have ignited a national mobilization unlike any seen since the early days of the space race. By January 2026, China had achieved a historic milestone. Domestic semiconductor equipment self-sufficiency reached 35%, up from roughly 25% just 2 years prior. Today, we examine how U.S. technology sanctions may have backfired, accelerating China's path to semiconductor independence, enabling the rise of domestic AI chip champions, and reshaping the global balance of technological power. This is not speculation. It is the documented reality of an industry transformed by pressure, policy, and unprecedented engineering determination. The U.S. strategy: containment through control. To understand the reversal, we must first understand the strategy. Beginning in October 2022, the U.S. Bureau of Industry and Security implemented layered restrictions targeting 3 critical choke points: advanced AI chips, semiconductor manufacturing equipment, and technical expertise. The controls were surgical. Chips exceeding specific performance threshold, particularly in computational density and interconnect bandwidth, were barred from export to China. Nvidia's flagship H100 and H200 GPUs, along with AMD's MI300 series, fell squarely within these restrictions. In response, Nvidia developed the H20, a China-compliant variant with reduced performance but retained market access. The logic was straightforward: deny China the computational firepower needed to train frontier AI models, while preserving commercial relationships through downgraded products. As one U.S. official stated at the time, "We are not trying to decouple, we are trying to de-risk." But this approach contained a critical miscalculation. It assumed that China's semiconductor ecosystem lacked the capacity, capital, or coordination to develop indigenous alternatives at scale. It underestimated both the strategic priority Beijing would assign to this challenge and the speed at which Chinese engineers could iterate under pressure. While Washington focused on denial, Beijing activated what industry observers have called a Manhattan Project for silicon. The 14th Five-Year Plan 2021-2025 had already designated integrated circuits as a core technology requiring breakthrough. U.S. sanctions transformed this policy priority into a national emergency, with funding, talent, and regulatory support flowing accordingly. China's response: the rise of domestic AI chips. The results are now visible. At Huawei Connect 2025, rotating chairman Eric Zhu unveiled a 3-year Ascend AI chip roadmap that reads like a direct response to U.S. restrictions. The Ascend 950 PR, scheduled for Q1 2026, will be the first to feature Huawei's self-developed high-bandwidth memory technology, a critical component previously dominated by South Korean suppliers. Key improvements include support for low-precision data formats optimized for large language model inference, a 2.5x increase in interconnect bandwidth for multi-chip clusters, and enhanced vector computing architecture. Bloomberg reports indicate Huawei plans to produce approximately 600,000 Ascend 910C units in 2026, more than double its 2025 volume, with total Ascend line output potentially reaching 1.6 million dies. Huawei is not alone. A wave of domestic GPU designers, dubbed the Four Dragons, have gone public on China's star market, signaling both investor confidence and strategic importance. More Threads, Meta X, Bayern Technology, and Inflame now offer alternatives for AI training and inference workloads previously dominated by Nvidia. Meta X, founded by former AMD engineers, saw its shares surge nearly 700% on its market debut in late 2025. More Threads reportedly tripled its revenue in 2025 as domestic cloud providers and AI labs diversified their chip procurement. 79. This is not niche substitution, it is ecosystem migration. As Wei Xiaojun, Deputy Secretary General of the China Semiconductor Industry Association, stated, "Blockades cannot stop progress, they will only inspire a stronger determination to innovate independently." That determination is reflected in hard metrics. In 2025, the added value of China's integrated circuit manufacturing industry grew 26.7% year-on-year, with AI-driven demand propelling memory chip output up 22.8%. The H200 restriction China's strategic countermove. Perhaps the most symbolic reversal came in early 2026. After years of U.S. restrictions on Chinese access to advanced chips, Beijing implemented its own controls, limiting domestic enterprises' purchases of Nvidia's H200 AI chips to education and testing purposes only. According to reports, Chinese officials instructed technology companies that H200 procurement approvals would be granted only under special circumstances, with university R&D labs receiving priority access. Commercial deployments, particularly in large-scale AI training clusters, would need to justify why domestic alternatives like Huawei Ascend or More Threads could not meet their requirements. This policy shift carries profound implications. First, it signals that China now views reliance on foreign AI chips as a strategic vulnerability, not merely a commercial consideration. Second, it creates guaranteed demand for domestic chipmakers, accelerating their iteration cycles and ecosystem development. Third, it demonstrates that technological interdependence is now a two-way street. Just as the US can restrict exports, China can restrict imports. For Nvidia, the impact is measurable. Analysts estimate the company's China market share in AI accelerators could plummet from 66% to as low as 8% by late 2026, driven by both U.S. export constraints and the rising competitiveness of domestic alternatives. Nvidia itself has acknowledged leaving billions in potential revenue on the table due to China-related restrictions. As CEO Jensen Huang publicly noted, U.S. export controls have effectively closed a critical market, and in doing so, may have accelerated the very competition they sought to contain. The irony is stark. A policy designed to preserve U.S. technological leadership may have catalyzed the emergence of a credible, scaled alternative ecosystem. The bigger picture self-reliance as strategy. China's semiconductor push extends far beyond AI chips. The 35% equipment self-sufficiency milestone reached in early 2026 reflects progress across the entire value chain. Shanghai Microelectronics Equipment now produces SSA 800 series DUV lithography tools at scale, enabling SMIC to achieve 7 nm yields through advanced multi-patterning techniques. While less efficient than ASML extreme ultraviolet systems, these domestic alternatives provide sufficient capability for the vast majority of commercial and industrial applications. Meanwhile, breakthroughs in ion implantation such as the Power 750H tool validated by China National Nuclear Corp have ended total dependence on Western suppliers for power semiconductor manufacturing. Critically, China is replicating its electric vehicle playbook, leveraging massive domestic demand to drive down costs, accelerate iteration, and achieve scale before global competitors can respond. Unofficial policy guidance reportedly requires new fabrication facilities to source at least 50% of equipment domestically to receive expansion approvals. As one observer noted, China is no longer just a consumer of chips, it is becoming a formidable manufacturer of the equipment that creates them. This shift has geopolitical ramifications extending far beyond semiconductors. It affects AI development timelines, defense technology trajectories, and the global distribution of technological power. Conclusion: Lessons from the chip war. The story of US-China semiconductor competition offers a cautionary lesson about technological containment in an interconnected world. Sanctions can delay, but rarely derail, determined innovation backed by strategic priority, capital, and talent. China's progress does not mean it has closed all gaps. Sub-5 nm manufacturing, advanced EUV lithography, and certain materials remain challenging frontiers. But the trajectory is clear. Every restriction has been met with accelerated domestic investment. Every denied component has spurred indigenous alternatives. For policymakers, the question is no longer whether China can achieve semiconductor self-reliance, but how quickly and with what global consequences. For businesses, the imperative is diversification, building supply chains resilient to geopolitical friction. For technologists, the challenge is ensuring that competition drives innovation that benefits humanity, not merely national advantage. As Wei Shaijun of the China Semiconductor Industry Association concluded, historical experience has repeatedly proven that closure will not bring lasting leadership. Only through openness and cooperation can fertile ground be nurtured for sustained innovation. The chip war may have begun with containment. Its resolution may require something far more difficult: reimagining competition as a catalyst for shared progress. Thanks for watching. If you found this analysis valuable, please like, subscribe, and share. For deeper dives into technology, policy, and global affairs, hit the notification bell. Bye for now, see you in the next video.